Hello, kiddos. A little bit of a review of what the last video was about. The A value right here is the first term in the sequence. Our R is the common ratio, like in this case we're multiplying geometric series or geometric sequence. We always multiply, but it's that number that we keep multiplying by. N is the number of terms we want to find the sum of. In a geometric series, we are trying to find the sum of a geometric sequence. This is a geometric sequence. For this series, we are going to add them all together. I'm picking small numbers. That way we can go back and do this all by hand later to check our answers and see that our equation does work. If you have not written this down, please do so. So the first thing we're going to do is kind of categorize and figure out what each value is. So A is our first term. So our first term is 2. And our common ratio, how did we get from 2 to 6? Well, we did times 3. And the number of terms that I would like to find the sum of, we're just going to keep our n nice and small. We'll keep it at a 4. So 2, 3, 4. That's going to be kind of nice. So let's see how this all works into our equation. So that's that's not good, right? Let's try this. Oh, there we go. That's better. So we are going to find the sum of the first 4 terms in this geometric sequence or series. And our A value is 2. So 2. And then it's going to be 1 minus our R value of 3 to the, I have to keep switching colors, 4th power all over 1 minus our R value of 3. And so now it's just some math magic of cleaning that up a little bit. So we have this 2 still right here. This is a 2. And then we end up with 1 minus and 3 to the 4th power. You could do it on your calculator, or it's just 2 3 squareds, which is 9. 9 times 9 is 81. And it's going to be divided by 1 minus 3, which is a negative 2. So as we go on and simplify this further, we end up getting our 2 still. It's out front. And then we get 1 minus 81 is negative 80 divided by negative 2. So we can actually cancel right here. That becomes a 1, and the negatives would cancel. It become positive. Negative divided by negative is positive. So we just get 80. If I could actually write here. There we go. It's just an 80. So that's what we get from the equation. Let's just take a look real fast and let's see if we could do this. And add our 2 plus 6, that's 8, plus, what is 18 plus 54? Well, that is 72, and 8 plus 72 is 80. So doing it by hand, we got 80, and the equation, we got 80. So the equation is going to be really handy to use when the numbers, especially whenever that n value gets much larger. Let's try another example here and see if we can work through this. So our A value, which would be our first term, would be a 5. Our R value, what do we keep multiplying by over and over again? And that would be a 2. And let's go ahead, we'll keep it nice and easy. We're going to go ahead and keep that n value at a 4, just to keep things simple. So let's go ahead and plug in. We have our S, and we're going to use the first 4 terms of the series. That's going to equal our A value, which is 5 times 1 minus our R value of 2, raised up to the nth power, which is 4, all over 1 minus 2. So now just simplifying. We have 5, 1 minus 16, all over negative 1. So that is going to be 5 times negative 15 over negative 1. So the negatives would cancel, and 5 times 15 is 75. If you take a look up here, well, let's just go backwards. 40 plus 20, that's 60, plus 10 is 70, plus 5 is 75. So we get 75 both ways. All right, so let's say what if instead of increasing every time, what if it is going down? Well, we're still going to find our a value, which is our first term. In this case, it's 48. What changes here is this rate. Instead of it increasing, it's decreasing. So dividing by 2, but in geometric sequences, we think of it in terms of multiplication. So dividing by 2 is multiplying by 1/2. And the number of terms, we're going to go ahead and keep it nice and simple here because we're playing with a new r value. And we're going to say that we're just going to find the sum of the first 4 terms in this geometric sequence. So we're going to go S of 4, that's the number of terms, equals 48, 1 minus, and this is going to be a 1/2 raised to the 4th power. So we have to do the 4th power for the 1 and for the 2, and it's all over 1 minus a 1/2. So we get 48, and this is going to be 1 minus, that is 1/2 to the 4th power is 1/16. And then 1 minus 1/2 is just 1/2. Well, if I do the top and the bottom by 2, so if I did of this numerator here, dividing by 1/2 is the same as multiplying by 2, so taking that 2 and multiplying it by the 48, it turns into 96 times, and then the 1 minus 1/16 is just 15/16. Well, these happen to cancel. 16 goes into 96 6 times, and 16 once, so 6 times 15, that is 90. And once again, we could add 48 plus 24. Well, that is going to be, 72? And then 12 plus 6 is 18, and 18 plus 72, that is 90. So again, just showing that the equation, the formula that we have right here, that we used, got us to the correct answer, just the same as adding them all up. So let's go another notch here, and let's go beyond what we've typically been doing. So you have 4 terms. Let's go to the 5th term here. So our first term, our a value, is going to be a 4. Our r value, how much it's changing by, is a times 3. And our n, that's the number of terms we want to find the sum of, is 5. Now I've done this with like 20 and whatever, it goes into the millions and billions, and you just need some calculator magic to help you get the actual sum of that. So I just want to use a little bit of a large number that maybe wouldn't be quite as simple to do the adding of all the terms in your head. So let's go ahead and let's do this. We have S of 5 to find the sum of the first 5 terms of the sequence. And it's going to be my first term, which is 4 times 1 minus my r value of 3. And this time it is raised to the 5th power. And all of that is going to be over 1 minus 3. So we still have this 4 times 1 minus and 3 to the 5th power. For those of you who don't know, that is 243. That is going to all be over negative 2. So simplifying this up a little bit, coming over here, we end up with, we'll keep the 4, why not? 4, and 1 minus that is going to be negative 242, all over negative 2. I'm going to divide this and this, so that becomes a 4 times now, it turns positive because the negative here turns to a plus. Plus because negative divided by negative. And dividing it by 2 is 121. So we end up getting 484. That is the sum of the first 5 terms of the geometric series. So hopefully you got a little bit of practice. Again, this is the formula you want to use over and over again, and hopefully that's just a little bit of seeing how this runs through. You get a little bit more comfortable with it. And if you have any questions, go ahead and let me know. I'd love to help you out.